Okay, great. All right, well, welcome to those of you who were able to join. Um, I know there's been a series of these things. I've not actually managed to join one up till now, but happy to sort of be hosting one. As many of you know, I'm part of an organization that may get to do STEM outreach. We had a meeting of folks across the country a couple weeks back, and discussing, what we can do in this era of coronavirus and everybody being separated. How can we offer some more events, leveraging all the cool stuff that Megit people are doing. And as is prone to happen, someone on the line volunteered Jeff to give a presentation. I always personally love when somebody else volunteers me to do something.
Yeah.
But he's jumped right on top of that and has actually volunteered himself. So nobody to blame but himself now.
Yeah.
Jeff is a part, I don't want to steal too much of your thunder, part of the BattleBots team. Whiplash is actually a family team, I guess.
Yeah.
And he's got his son, Matt, along with him tonight. I appreciate them taking the time to do this and share what I'm sure will be some interesting stuff with us. And with that, I am going to shut up and hand it over to you guys.
All right, well, thanks for having us. And so we're a BattleBot team. We compete on the show BattleBots, which is on this Discovery Channel now. I've been doing it for about 18 years. I started way back in the Comedy Central days. And my two sons, Matt and Jason. Jason isn't here right now, but Matt loved it from when they were little guys. And they kind of grew up with it, and they started competing on their own about 10 years ago, 12 years ago, in some smaller weight classes. And here we find ourselves today fighting, the best robots in the world on national TV. So it's been a wild, crazy ride, but a great ride. It's given Matt and Jason both some guidance as far as their careers and their school. Matt is a junior at Cal Poly Pomona. Senior. Wow. Oh my God. I guess I haven't got that tuition bill yet, but at Cal Poly Pomona in electromechanical technology. And my younger son, Jason, is at Chico State in mechanical engineering. So it's been a great thing for our family, a great thing for the boys, and we love it. It's been a great hobby and sport, and we've been able to turn it into other things. We've done a lot of TV commercials, and we've done TV shows like The Big Bang Theory. I did the robots for that show. I've also done robots. I just did them for a show called The Neighborhood that's on CBS. And done many commercials and worked on some movies because of BattleBots and robotics. And it's just been a great thing to do. So, I'm really happy that Matthew and Jason are interested. I'm very lucky in that way. And we're lucky that we get to do this as a family. My wife, Debbie, their mom, is the team manager. So she manages all the social and the online presence and ordering the banners and the stickers and the paint and all the things, the little things that we need. Matt's our driver, and he did all the CAD designs, so I'm sure you'll have a few questions for him. And he's known as one of the best drivers, if not the best driver in BattleBots, so we're lucky to have him. And we'll take you on a tour of the garage and show you what it takes to build a BattleBot, and the different tools we have, and what the BattleBots are all about. So I guess you guys have any questions you want to start with?
You just walking around.
Any questions yet? Anything?
Let's just make sure everybody's awake out there, right?
Yeah.
Well, I'll throw one out to start off. You mentioned having done this for 18 years, and I'll admit to not having watched the show since probably the first 3 or 4 years.
Right.
The only place I've seen it is, in fact, You mentioned Big Bang Theory. That's the only place I've seen it more recently than that. What's sort of been the evolution for you over those years? What's
Well,
just the dynamics of what you have to do changed a lot?
yeah, I mean, the robots have gotten much more deadly, way more powerful. The power density of batteries has really added to that. So, we started with wet cell batteries even and gel cell batteries and NiCads, nickel cadmium batteries, and then it went to nickel metal hydride batteries. Now we're using lipos, which have amazing power. I mean, we're routinely pulling between 150 and 200 amps. I guess a good way to start would be to kind of show you what the robots are made of and go from there. So I'm going to hold the iPad, and Matt, you can show them what everything is and the different materials involved. So let me know that you could see. So as you can see, we have two BattleBots, and this is our primary right here. Okay.
So when he says we have two robots, what he really means by that is you're dead.
Okay.
What he really means by that is in BattleBots, you're allowed to have like different configurations for your robot. So if you're fighting like a vertical spinner, you might want to have some like certain armor attachments. Or if you're fighting like a different type of weapon, you might want other armor attachments. So instead of having different configurations, we have two identical robots that have like slightly different armor, slightly different weapon. So like this one has, the big,
sorry.
This one has the big disc spinner on the front. So this spins at like 4,000 RPM, and it'll just take pieces off robots and throw them in the air. And then this one here does not have the disc spinner on it. But the reason for that is because we need weight to put a giant plow on the front, which is so this one has this giant plow that attaches to the front of the robot, and it weighs like 50 pounds or something. So like this is if we need to be really defensive, we'll use this one. And if we want to be more offensive, we'll use this one. So, and another part of having two robots like this is in BattleBots, you need a lot of spares because, I mean, obviously you're going to take a lot of damage. So sometimes you don't have time to fix in between fights, or sometimes you don't even have enough time to like charge your batteries before the next fight. So you need to have spares of everything. So like say this one gets completely totaled in one fight, what we'll do is we'll get the second one ready, and then while that one's ready to go, we'll start fixing this one. So it's gotten to the point where there's, you have so many matches in such a short period of time that you really need two robots to be competitive these days.
Okay, there. So why don't we show you the insides, the guts of a robot? And one thing, our main weapon, believe it or not, is not only, sorry guys, is not only this disc, which weighs 25 pounds. It's made out of AR 500 steel, which is bulldozer blade, what they make shooting targets out of, but the arm goes up and over 180 degrees. So we can lift and flip other robots. We're the only robot in BattleBots that has two primary weapons, basically. That we have the lifting arm, which we can lift and flip other robots, and we have a deadly weapon in the spinner. Also, if we get flipped over, we can use the arm to flip ourselves back over, which we have done a few times. So, Matt, why don't you give them a tour of the guts of the robot? Okay, just tell me where.
So, pretty much, BattleBots are probably more simple than any first robot you'll ever build or see in competition. When it comes down to it, they're really just giant RC cars. I mean, you have like a receiver that's right here, then you have motor controllers, and then you have your motors, which, turn your wheels or spin your weapon or lift the arm. Okay. Or lift your arm. So really, they're giant RC cars when it comes down to it. I mean, they're obviously a little bit more complicated, but most of the time people try to avoid things like sensors and things like that, because if something like that gets damaged, like you're kind of done. Like you don't want, one sensor to get damaged and you're just driving in a circle for the whole fight. So a lot of it is just making it as simple and robust as possible. But yeah, so this robot, we have 4 drive motors that are about 3.5 horsepower each. So we have about 7 horsepower per side on drive, and then another 7 horsepower spinning the weapon. spinning the weapon. And then we have like a 4.5 horsepower motor that lifts the arm. But,
Let's show them the other side as well. Yeah, show them the other
Okay,
side.
can you turn the camera around on this side?
Hang on. Hold on, guys.
Let me see. There. There you go. Here, let me film you.
Okay. All right. So let's go through this. So I'll tell you what this thing's made out of. This is AR-500 steel. Okay. This is bulldozer blade, and what they make shooting targets out of. People actually shoot at this stuff. It's bulletproof. All right. The chassis is all aluminum. Okay. It's welded aluminum. We did it all in-house. These are the supports. The uprights are water jet cut. All 6661 T6 aluminum. Now, one very interesting thing. Okay, so our top lids are titanium. Okay, it's grade 5 titanium, the best titanium you can get. We need this because it's got a great, it's very resistant to getting damaged, even though this is torn, and we'll show you some other damaged pieces, but it's also light and extremely strong. Believe it or not, we have plastic. These arms are UHMW plastic. It's the same kind of plastic you have on your cutting board at home in your kitchen, but they're just humongous pieces of it that we have water jet out, and we mill them, put them on a mill, and to put these parts in, these recessed parts. This wedge up here, this is also AR-500 steel, and you can see the edge is already damaged a little bit. We'll clean all that up, but this steel is really extremely tough. So while I got you here, I'll show you. So this is how our weapon system works. These two motors are slaved together with this chain here. Each of these put out about 3.5 horsepower and spin at 6,000 RPMs. We run at 6S batteries, which are 24 volts approximately. So these two motors are spinning this belt. This belt goes to here up to the weapon, up to the disc. So that's how we transfer the power over. And it's been a very robust and good setup for us. We've never had any problems with it. On this side, like here we have the receiver the man was talking about, and then here's the speed controller. So you guys might use VEX speed controllers. These are the big brothers of the VEX speed controllers. These will handle 300 amps and 60 volts. And believe it or not, we've still burned them up. So one big thing is we use a lot of duct tape in BattleBots because it works. And these are kind of interesting switches. I'll show you how they work. One quick second. They screw in and out. We can't use switches because of the shock loads. The G-forces, someone had some G-tape on their BattleBot last season. I think the G-force was 120 Gs in one shot. So those normal switches, you know, there's nothing that you can use that will hold up except for these special switches, which are made by a team, BattleBot team, and you screw them in all the way in to either turn them on or off. And these will handle 300 amps, so that's what we need. We use really heavy wire. Everything's at least 10 gauge throughout, except for the smaller electrical wires. Back here is the lifter motor, kind of tough to see, but here's the lifter motor here. It's a long mag motor. It's about 9 inches long right there, 7 inches long. And then it goes to a 50-to-1 gearbox, which is right here. So the 50-to-1 gearbox goes to this sprocket here. And this is 50 pitch chain. This chain will lift 5,000 pounds. It's the only thing that will work. We've broken heavy duty 40 pitch chain, which goes up to 3,500 pounds, and that wasn't strong enough. So these are hardened sprockets, special custom hardened sprockets, because we've broken sprockets before. They just literally exploded. So through this, the gearbox goes to the sprocket to the chain, to this sprocket, which lifts the motor. It's keyed and everything in there, so it grips it pretty well. These tires are kind of interesting. These are custom made for us by one of the BattleBot teams in Brazil. They're vulcanized rubber on a aluminum hub inside of it, so they are extremely tough. And in our matches, if you go on YouTube and you search for BattleBots Whiplash 2019 or 2018, you'll see a lot of times we lost wheels. We won the fight, but we lost wheels and stuff. And that's a tough thing to deal with because it counts points against you. To make a long story short, we got tired of that. We were using these kind of wheels, which are carefree wheels. They're foam. Can't have air. You need a solid wheel. So these wheels are filled with foam, but they get broken off. You can see the damage to the rims and stuff. So this is a kind of off-the-shelf solution. We've switched over to a custom solution because you need them. Because if you get hit in the wheels, you're really in trouble. So that's it for basically how the robot works. So as Matt said, it's basically an RC car on steroids and a half. It's a Terminator. So you guys have any questions?
Hi, I have a question.
Sure.
So when designing these, do you go through like stress calculations, or is it just kind of more intuitive than kind of guessing on size and thickness of materials?
Both. Matt designs it in CAD on SolidWorks. Matt needs to go, so thanks, Matt. He's got an exam. So he's doing college right now, so at home. So in any case, yeah, we do he designs it in SolidWorks, and you can do the stress analysis and weight and balance and all that. And so we do some math to put them all together to figure out what we're doing.
So I see a whole bunch of questions popping up in the chat here. I'll read them out to you to give you time to go look into them. I guess first one sort of on the personal level, how did you get started with us?
Basically, I've been a gearhead all my life, and I love building things and breaking them. And so I did RC airplanes and RC boats. I raced RC boats for many years. And when I saw BattleBots on TV, I got the pay-per-view and I said, I have to do that. And so I had a really good background in RC. And some of the stuff that we needed, the batteries, the chargers, the radios, all that kind of stuff. So I didn't know what I was doing, and I built 2 robots and took them to BattleBots, and I did pretty well for a first time. I won several fights. I built 2 robots, actually. I took 2 there, one a lightweight and one a middleweight. And basically, I just fell in love with it. It's so much fun. I cannot even put it into words. It's a lot of work, but it's so much fun. It's worth it, every penny of time.
You made the joke about breaking stuff. I've always discussed with the team, the underrated value of the person who knows how to destroy things in a test, so that you don't destroy them when you're using them for real.
Exactly. I excel at destructive testing.
There's a couple questions here that go to the preparations for a particular, I guess you would call it a filming season.
Yeah.
How much time you have, to come up with an idea, develop a design, what the average cost is, and also kind of what intelligence, let's say, do you have about the competition you'll be facing?
Okay, so those are great questions. I'm just going to put that down. You guys can see me all right? Okay, so basically as far as that goes is you never have enough time and you never have enough money, but mainly you don't have enough time. What happens is that due to TV, there's no guarantees. So, and with COVID, it's just really gotten crazy. To answer your question, we like to get 6 months, and we kind of have an inkling about 6 months before, but nothing ever gets finalized until at least 60 to 90 days before the event. And so to build a robot in that time and make the commitment of time and money and resources is very tough. But everyone does it. I mean, if it wasn't for COVID, there'd be probably 100 robots there. We're going to be taping in 2 weeks, so that's why the robots aren't finished painting and everything. From October 2nd to October 15th, we'll be in Long Beach filming the show with, I think, almost 70 other robots. And believe it or not, some from robots from around the world, actually. A couple teams managed to quarantine here. flew in, shipped their robots, quarantined, and will be here. So it'll be in international competition. If it hadn't been for COVID, there'd be 90 robots. And to answer your question about how we, do figure out who we're fighting, it's this experience in YouTube and, knowing everybody and seeing their fights and it's just kind of experience, yeah. We just try to figure out, that's when we built the robots and we kind of have an idea, and I'll take you around and show you some of the different armor pieces we have. But each robot has its own thing. For a horizontal spinner like Tombstone, we have one armor configuration. For a vertical spinner like Bite Force, we have another armor configuration. So it depends. If we have a flipper like Bronco, we have a different idea for how to deal with that. And the thing is, they have to do the same thing to us. So it's a big, humongous game of rock, paper, scissors.
That's a good lead into one of the other questions I see here, which is, from season to season, do you tend to take the same design and improve on it, or do you say, oh, let's start with a blank piece of paper, or maybe you see some other robot and want to improve their concept?
Okay, so that's a great question, and basically the best way that I found to be successful in robotics or any kind of competition is to iterate. So Whiplash was designed by Matthew, and I don't know if I can find it here, but this, one quick second, I'll be right back. Anyway, sorry about that. Whiplash started as a 1-pound robot from that Matthew design. So a 1-pound robot is called an Antlate, and that's about this big. So he was about 8 years old, and he made a robot called Splatter, and it had a lifting arm with a saw blade on it. Maybe it was 10, but anyway. So when we decided we wanted to go to BattleBots, our first robot basically looked like this, but it was very, very different, not nearly as refined in any way. So we did horrible the first season of BattleBots. We did mediocre at best at the second season of BattleBots. But the key thing is, we took the same robot. Then we went to a tournament called Robo Games up in San Francisco, which we took second place. And that's basically BattleBots, but not on TV. It's just the best competition in the world because it's got all kinds of everything from sumo wrestling robots to hockey bots to BattleBots to everything. And we got second, and because we iterated. So we got better. The robot got that much better. And then when we went in a couple years ago, we wound up coming in fourth place because we had just come off Robo Games, and the robot was working perfectly. And we knew the strengths, we knew the weaknesses, and our robot was better iterated than most of the other robots. It was very highly developed at that point. So now we have the same basic design, but we've just improved the pieces of it, like the tires, okay? The tires are improved. The armor is improved. The way we build it, our ability to design and to actually build a robot has gotten much better. Our welding is much better. We did all the welding here. I have a welder. I'll show you that in a bit. We have certain sponsors, like a water jet sponsor, to cut some of the material. But other than that, we built pretty much everything here. So yeah, we iterate. That's the best way, in my opinion, is get a design that you think is good and, beat it to death until it works.
Actually, should have read the question exactly as it was written because someone used the word iterate in there. One question that I actually wrote down, not on the chat, it's mine. You touched on the wheels again there and the switch earlier. I think you mentioned things that were designed or produced by teams. Is that a thing that happens where teams sort of have a special feature and they then arrange to get that out to other folks?
Yeah. So there's one team, it's called Waiachi, believe it or not. They're from Wisconsin. They make food processing equipment and cow milking machines, okay? And they went to BattleBots 18 years ago, and they came in with uniforms, and they were totally impressive, and they made some awesome robots. Their claim to fame was Suno Ayachi, which was a humongous horizontal spinner. It's like 3 sledgehammers swinging around at 600 RPMs or something. Anyway, so they morphed their business into making parts for us. They'll custom make parts, but like these switches that I showed you, they're custom made by them. They do all the machining. They built all of us blades custom, like S7 tool steel blades that, with special custom tapers. They make the gearboxes. We all use Waiachi switches. A lot of us use Waiachi gearboxes. Other guys, like there was a robot called Biohazard, and that guy Carlo Bertocchini, he put together a company called Ampflow, and they make the motors that we use and the gear chain boxes that we use. The gearboxes that do the drive are not gears per se; they're chains. There's actually 3 sprockets in there because it's more cost effective. The gears are the way to go, but these are 95% as effective and durable, and they're much cheaper. So yeah, there's companies and guys who make parts for other people. Quite a few, actually.
You make anything for anybody else? Or?
No, we have enough trouble making for us. Not yet. We gave some people some good ideas. We've stolen a lot of great ideas, and we've passed those on, and people have stolen great ideas from us as well. So, like the slaving the motors, that's something. And I'll show you one thing. Give me one quick second. This is basically our claim to fame. So I was telling you about the Ampflow company. They make these gearboxes, and the gearbox is designed for one motor to go in. But what we did is we attached a second motor going the opposite way, and we slaved them with the chain and sprockets. So in this package, we have 7 horsepower at 6,000 RPMs. It has the chain drive in here. So this compact package gives us a good amount of space. We save space, we save weight, and we gain power. And the key thing is that we're pulling literally between, conservatively, 150 amps, okay, at 24 volts. I mean, you could weld with that kind of voltage. So these motors, even though they're really robust, very expensive, and tough, they still, you're putting hundreds, if not thousands of watts of juice through them. So to make a long story short, the motors would basically explode. So because the commutators would get so hot. So what we did was we used 2 motors. Each of these motors has 4 commutators in it, and 1 commutator and 4 sets of brushes, or 4 brushes rather. So we have 2 commutators, 1 for each motor, and 8 brushes. So we've dispersed the voltage, and the motors have never let us down. We burned up so many motors. I mean, I've got a pile of burned ones. So that's our claim to fame.
Anybody else out there got questions? I see one more I haven't read yet on the chat, but
I got one more question. So is there a weight limit designated by BattleBots, or do you choose weight reduction, or do you make those weight reduction choices based on?
BattleBots has rules. The weight limit for BattleBots is 250 pounds. Each of these robots weighs 250 pounds. So, and basically as far as size, it has to be able to fit through the door. So I think it can't be more than 8 feet wide. There is, however, one interesting thing, which hopefully we'll see this year, is there's a walker bonus of 250 pounds. So you can actually have a 500-pound BattleBot if your robot is a true walker. And that doesn't mean like locomotion or shuffle. It actually has to have legs. that aren't based on rotation that will actually walk. If you can do that, you can build a 500-pound robot. There's other limitations as far as there's no, you can't shoot a laser in your opponent's eyes. You can't, you can't release liquid all over the arena. But you can have flamethrowers. They started to allow projectiles, but you have to have your weapon checked before to make sure it won't go through the walls, the Lexan of the BattleBots. The BattleBots has got 1.5-inch Lexan bulletproof glass on the bottom layers. So you need to ensure that your robot can't get through that, can't damage it, because it would be bad. So.
Anybody else?
Hello. I have a follow-up question on this. So most of the kids that are on here have done a lot of robotics building for FIRST, which is more so than anything, a lot of rules to adhere to. So if you can maybe give us an example, not just only on the mass and the power budget, but what are some other rules, and how big are the rules that you have to go through every year? Do they change, and how much have they impacted your design of the robot?
The rules, I mean, that's a great question. And the rules do change every year. They get refined every year. There's one thing, there's a famous rule, if you're a BattleBot fan, is no entanglement devices. In other words, they don't want, because it's a TV show, they don't want it to be boring. And if someone came out and shot a net over a robot, we'd just be stuck, okay? And that's not what people tune into BattleBots for. So there's no entanglement devices. Well, someone figured out a way. That was the language before said no entanglement devices, but then they changed the language to something else that was like no nets. Okay. Well, someone figured out that they could make an entanglement device that wasn't a net. They used it, and it caused a big brouhaha. And so things like that do happen. The rules, they're mainly pertain to safety. I mean, 250-pound weight limit, it's got to be able to fit through the doors. It has to have safety. So all these have fail safes. So what they make you do is you run your robot on a stand like this with the wheels not touching, full speed, and you have to turn your radio off. The robot has to shut down everything. It's got to, the wheels have to stop, and the weapon has to stop, and the arm needs to stop, and whatever you're using needs to stop. That's set in stone. But like I say, most of the rules are set for safety. They don't want to see sloppy robots with wires, exposed metal contacts and that kind of thing. So we go through a stringent safety requirement. Everyone goes through safety before they're allowed to compete. Basically, they're kind of opening up to different kind of weapons and different ideas. I mean, one thing I was trying to think of how to do is to do maybe a plasma cutter. That would be really cool. It would look really cool, and if you could get it to work, it'd be something really cool. I'm not sure how they would allow that, because you would need a lot of batteries, and it's very tricky. But guys are just, if you watch a show, there's a robot called Huge, and those guys figured out how to mechanize a rickshaw. I mean, it looks like a cart from Horse and Buggy, and they put a weapon on it, and they almost beat us. Very popular robot, very clever guys, well-designed robot. So, there's a lot of rules. And as far as the time, because it's TV, you don't get the final go until very late in the game. So, BattleBots was supposed to be shot in April. We found out in January that the network approved it and it was a go, and then it got canceled, and then we found out probably 6 weeks ago that it was a go now. So it's 6 to 8 weeks ago. So, mostly everyone had their robots built or in some state of readiness, and now everyone's just crunching to fix it. And there'll be guys, when we go there, who are fixing the robots and finishing them in the pits. We'll be done, so that's a good thing. Anything else?
Right, so I held this question back for a little bit on the chat, because I think it's a good capstone to a lot of what you've been saying. What has been your favorite BattleBot that you've made, and what's been the favorite that you've seen other people make?
Well, that's a great question. Okay, my favorite robot is this Whiplash. This encompasses. It's been great since I did it with the boys, and it's been a great design for us, and it's just been really gratifying. And I like that it's unique. You know, it's got 4 wheels like most other robots, and it's got a vertical weapon, and it's got a lifting arm, but no one really has put all that together like this robot has. Like I say, we're really proud of the fact that we have two really powerful weapons. No one else, most guys can't even handle one weapon, so that's pretty good. Of the other robots that I really love, my all-time favorite robot is a robot that we actually beat in 2018, and that's called Warhead. It's made by some guys in the UK. It literally had wings, and it had a huge horizontal spinning head that was articulated. Just a beautiful machine. It was just a work of art that was deadly. And they could take the spinning head weapon off and put a Tyrannosaurus Rex head on it with a crusher on it that shot flames. And that was just it's an elegant design, incredibly effective, just great robot. Even the remote control was custom made. They custom made it so that their hands could manipulate everything on the robot. It was just a work. Everything about that was a work of art. Of course, I like old school robots like Biohazard and Dissector. Of the new robots, I don't know. Chomp may be coming back because they. The stuff that they did was really advanced. They actually had sensors, so they had a pneumatic hammer, a pick, and it was fired by sensors. So when you got within a certain proximity of the robot, it would fire the hammer and would also chase you. So it would also have a little bit of autonomy to it, and that was a really interesting design, and it was really something. So I mean, the robots are going to go to that. But you know, it's you got to go with tried and true if you want to win for a while. You know, it's like anything else. So.
I forgot I put it on mute because the dogs are going nuts. Yeah, I think that's all the questions we have on the chat here.
Okay.
Anything else you wanted to go over, or should we move toward wrapping up?
You know, I hope you guys watch the show. And you know, if you get a chance to compete, it's really an amazing experience. Normally they have audiences, but the set is closed now. There's no audience. If they the next time there's an audience, you should go. You won't even believe what you're seeing. It's the coolest thing. And you know, I'm just really lucky to be doing it. It's a lot of fun, a lot of work, but it's worth every penny and every second. So, you know, it's a good thing to do.
All right, sounds like a lot of fun. Let me do this. I'll throw you a leading question because we want to make sure we plug Megan a little bit here.
Right, absolutely.
You're doing all this while you got a full-time job.
Yes.
How does that fit around what you have to do? And maybe for everyone here, they've heard me talk about what I do too many times. They'll roll their eyes and be bored. But maybe share a little bit about what your job is and the kind of cool stuff that you get to work on when you're not working on this cool stuff.
Cool. Great idea. So I work at Meggitt in Simi Valley at Airframe Systems, and basically I work in the engineering R&D lab. I'm the senior engineering technician. So basically I get to break things, build things and break things that all the smart guys think of. And a lot of what I work on is fire detection and suppression. So the bottles that actually hold the fire agent, and then the detectors that detect the fire or smoke or whatever they're looking for. So that's something that we do. I've worked on actuators there for military aircraft, like the canopy actuators for F-16s. I was on that project for a while. That's pretty big. It's been a great place to work. I highly recommend it. The people are cool. The company's awesome. We could not do this without Megan. Megan has really stepped up, and they love it. We've taken the robots there and shown everyone there. They're very well received. Everyone asks me about it. Everyone loves it. Like I said, they've been incredibly supportive, and the job's a lot of fun. I mean, I'll just tell you, like, but okay, so these are new. This is new titanium for the tops of the robots, and I have no way to cut this here, but we happen to have a shear in the shop there that can cut it. So, you know, I asked my boss, he said, sure. So I went in there and I was able to cut it, and they're pretty cool there. And everyone asks about it and really into it. So it's a lot of fun. It gives them some they feel like they have a little bit of ownership to it, which they do. So, yeah.
Check around one more time. Anybody got any final questions? You've been dying to ask.
I have a question.
Yeah, please.
For wiring for the robots,
Uh-huh.
what's the most tedious, like what's the most hardest part about wiring robots like that have a lot of moving parts?
You know, the connectors and making sure that the wires are really in there. I'll try to show you guys. I'm not very good with the camera, but so we use super heavy connectors. Let me bring it around and I'll see if I can do this. I don't even know what I'm doing here, but okay, so if you can see these connectors right here. Where's the, oh, here. Okay, I don't know if you can see them. These connectors are gold connectors. They're 6 millimeter, and they carry roughly, you know, 100 to 200 amps through them. So when we wire them, we also, it's a little messy because we just painted, but I don't know if you can see, but we shoe glue the wire to the connector as well to make sure that it doesn't pull out. These are even bigger, 8 millimeter connectors here. I don't know if you can see that. Oh, sorry. Shoot. Hello? You there?
We can still hear you. We lost your video feed, though.
Oh, I don't know why. Okay, sorry about that. Hang on. Let me see if I can find this.
While you're doing that, I'll say that's got to be the smallest connector I've ever seen capable of carrying. You said 200 amps, right?
Yeah, yeah. That's what we have, 2 of them. Shoot, I don't know how to get this back. Darn it. Guys, I don't know. I think it somehow cracked out on me. Are you back? Are you there? There we go.
Yeah, there you go.
Okay, sorry about that. So, yeah, and you can see the gauge of the wire here, if I can do this correctly. So I don't know what I'm, okay, so there, can you see that? Yeah, I think you can see that. The wire there. You know, it's just making sure all the wires stay where they're supposed to. Like, see, these are all screwed in, and they're ring terminals, but we also shoe glue the wires to that. And one crazy thing is, okay, so these motors, you know, motors have magnets in them. I think you can see these mag motors. We take the motor completely apart, and then we epoxy around the outside of the magnet inside the motor, so inside the can, so that they will be resistant to shock, because frequently we have literally torn motors apart, and they've shattered. The magnets will break inside of the motor, so or they come loose, so we epoxy them. This is actually a magnet from a motor. It's a neodymium magnet. They're really good motors. These are really, really strong magnets, but you can see what happens to them when they take huge shocks. So, let me see, anything else? Let's see. Anything else, guys?
Well, the fun of Zoom meetings comes up again.
Yeah.
Gonna make last call here. Any questions out there? Well, we're just about at an hour anyway.
Okay.
I'm gonna go ahead and thank you for doing this evening.
Sure.
I'm spending the time to share with these guys, some of the cool stuff that you've done.
Great.
We wish you tremendous success. I hope there'll be
Thank
a
you.
fair number of folks on the line now watching
Mm.
when it comes out.
Yeah, absolutely. The show should be on probably in a month or two. They're going to try to get it on this year. So yeah. Thank you very much. Sorry for my horrible camera work, guys, but I don't know.
We're all trying to learn new skills in the midst
Yeah,
of this. So,
it's the first time I've used Zoom on my iPad, so I'm kind of making do. So you guys are the guinea pigs. So, and this is the rest of our shop. I'll just show you some of the other stuff. Well, I got it out. So see, these are different armor pieces and configurations that we painted. And we need spares, lots of spares. This is all AR500 steel getting ready to be painted and welded together. So you can see we have extra discs there. So we have plenty of everything. So hopefully it will all work. So, great.
is that Maggot green paint, by the way?
Yes,
We'll
it
have to
is.
tell the
This,
color
you
registry
have
and
no idea what
computer
this
here.
screen took to get. This is custom paint in custom Maggot green spray cans. This paint is custom made for us to match the Maggot green.
All right.
So we've got all the Maggot of these. I'll show you over here. So we have the Maggot banner on our cart and everything, and we're pretty proud of Maggot, and they've been great to deal with, and it's a great place to work. So we try to put the name out as much as possible.
All
and
right.
the color.
Good plug there. And
Thank you.
once again, I'll thank you, wish you good luck. And normally at this point, I would present you our thank you gift, but the couple of T-shirts hopefully are on the way to you.
Oh, yeah. And like I said,
you can enjoy some Team 589 blue along with your Maggot green.
great. Thank you. Thank you. And we're going to send you guys a bunch of Whiplash decals and wristbands as well. So I'll make sure you get those marked as soon as possible.
All right, thanks again. Have a good evening, everybody. And Brian, thanks for your help setting this up. Being the
all right, guys. Thank
tech
you.
guy in the background.
All righty. Bye.
Night.